We now discuss the solution of a problem that appeared in the joint entrance examination main held on 26th June 2022 in the second shift. The problem is on the probability. This question is from the section Statistics and Probability. The given question is, if the probability that a randomly chosen 6-digit number formed by using digits 1 and 8 only is a multiple of 21 is P, then 96 times P is equal to. We have to first form the 6-digit numbers using the digits 1 and 8 only. Use the digits 1 and 8 and form all 6-digit numbers. From these, a number is randomly picked up, and that picked up number is a multiple of 21. If the probability of picking up a number from these 6-digit number, which is a multiple of 21, is P, if the probability of picking up such a number is P, then we have to find out 96 times P. Agreed. We now discuss the solution of the problem in detail. First of all, how many 6-digit numbers are formed using the digits 1 and 8 only? That's the question. So, for that, we have to fill up 6 places by the digits 1 and 8 to form all 6-digit numbers with the digits 1 and 8. So, 6 places are there, and the digits to be used is only 2 elements, 1 and 8. So, to fill up a place, we have 2 choices, 1 or 8. So, first 1 or 8, second 1 or 8, third, fourth, fifth, sixth, 1 or 8. So, thus the number of 6-digit numbers formed by the digits 1 and 8 by the product rule of counting is. So, for each place 2 choices are there. Use the product rule, 2 cross 2 cross 2, 2 cross 2 cross 2. That is 2 cross 2 cross 2 6 times. That is 2 power 6, that is equal to 64. So, this is the by product rule. Each place can be filled by 2 choices. So, the total number of 6-digit numbers are 2 into 2 into 2 6 times. That is 2 power 6 is equal to 64. That means we have found the sample space in this discussion. So, let S be the sample space, that is the set of all 6-digit numbers formed by the digits 1 and 8. Then the order of the sample space, that is the total number of outcomes, is 64. Now, what is to be done? So, we have to randomly choose a number from this set S. That randomly chosen number is a multiple of 21, then it is a favorable outcome. The question is, how many of the numbers of S are multiples of 21? That means, what is the total number of favorable outcomes? That's what you are asking. So, let X be any element of S. So, that X is a multiple of 21 if and only if it is a multiple of 3 and a multiple of 7. So, X is a multiple of 21, then 3 divides X and 7 divides X. We first enumerate all the elements of S which are divisible by 3. Then later on we will come to the point 7 divides X. Let T be the set of all X belongs to S such that 3 divides that number X. We continue in the next slide. Agreed. Now 3 divides any number. What is the divisibility rule for division by 3? Take that number, sum the digits of that number, and that sum is divisible by 3, then 3 divides X. So 3 divides X if the sum of the digits of X is divisible by 3. So let's see who are they. First, if each digit of X is 1, that means the number is 1, 1, 1, 1, 1, 1, 6 ones. Then the sum of the digits is 1 plus 1 plus 1, 6 times, that is 6. 3 divides 6, therefore 3 divides X. Thus, this number 1, 1, 1, 1, 1, 1, that is 6 ones, belongs to T. And what about all 8? That is 8, 8, 8, 8, 8, 8. So the total number of digits, the sum of the digits of X is 3 8s are 24. So 3 divides 24. 6 8s are, 8, 8, 8, 8, 8, 8. 6 8s are 48. 3 divides 48. Therefore, that number belongs to T. So, similarly, 8, 8, 8, 8, 8, 8 belongs to T. The reason is, sum of all the digits is 48 and 3 divides 48. Therefore, 3 divides this number. Therefore, this number belongs to T. What are the others? That is the question. Suppose your 6-digit number has 3 8s and 3 1s. If you have 3 8s and 3 1s, then the sum of the digits will be 3 8s are 24 plus 3 1s are 3. That is, the sum is 27. 3 divides 27. Therefore, 3 divides X. If X has 3 8s and 3 1s, then sum of the digits of X is 3 into 8 plus 3 into 1, that is 27. And 3 divides 27. Therefore, 3 divides X. Therefore, X belongs to T. For example, let us see one or two. I will show you what are those which have 3 8s and 3 1s. So here is an example. 8 1 8 8 1 1. This has 3 8s, 3 1s. 1 8 1 8 1 8. This has 3 1s and 3 8s. 3 8s. So also, so now the question is, how many of the elements of T that have 3 8s and 3 1s? That's the question. So the number of elements of T with 3 8s and 3 1s is, so you have 6 places. 6 places. And 3 of them of one type, that is having 8. And the remaining 3 of them of the other type, that's of each is 1. So the number of elements of T with 3 8s and 3 1s, use the formula from the combinations, 6 factorial by 3 factorial into 3 factorial, and that when simplified you get 20. So that means how many elements of T that have 3 8s and 3 1s? There will be 20 of them. And it may be noted that any element of S other than the above 20 with at least 1 8 and at least 1 1 not divisible by 3. So you take any 6-digit number with 1 and 8 as the digits, and which has at least 1 8 and at least 1 1. Right? Agreed? And that is not divisible by 3. For example, you take 8 and the remaining 5 are all 1, 1, 1, 1. And it has at least 8, 1, 8 and at least 1, 1. And the sum of the digits is 8 plus 5, that is 13, and 3 doesn't divide it. So therefore it doesn't belong to that one. So now the elements of T are all completely determined. And who are they? T consists of 6-digit number with each digit 1, 6-digit number with each digit 8, union the set of all x belongs to S, where x has 3 8s and 3 1s. How many? What is the order of T? The order of T is, this is 1 plus this is 20. So the total is 22. So this is the set of all those x belongs to S, 3 divides x. Now the question is, how many of the elements of T which are divisible by 7? That number will be the number of favorable events. We continue in the next slide. Agreed. Our claim that I make is 7 divides every element of T. So you take any element of T, 7 divides that one. So all the elements of T are divisible by 7. That's what my claim is. Let us see first. 7 divides 1, 1, 1, 1, 1. Now do it by actual division. You do it by actual division and 7 divides this number. Otherwise, use the divisibility rule by 7 and 7 divides this number. Now 2. 7 divides 8, 8, 8, 8, 8, 8. Why? Because 7 divides all ones, 7 divides all sevens. Yes, 7 divides all ones, we have seen in 1. 7 divides all sevens, obviously. So 7 divides the sum, that is all 8s. Agreed? Right. And what about let x belongs to T and has 3 8s and 3 1s. Such numbers are also divisible by 7. For example, you take this number 188, 181. This has 3 8s and 3 1s. Therefore, this is divisible by 3 and is also divisible by 7. How do you say that? Now 7 divides this number. Why? Because this number is the sum of all ones, 1, 1, 1, 1, 1, 1 plus 7, 7, 0, 7, 0. Okay? And now 7 divides this number, 7 divides this number. Therefore, 7 divides this number. So, that means 7 divides any number with any 6-digit number with digits 1 and 8, where that number has 3 8s and 3 1s, and that is divisible by 7. So thus 7 divides every element of T. Agree. We have already seen 3 divides every element of T. Therefore, 7 divides every element of T and 3 divides every element of T, and the GCD of 7 and 3 is 1. Therefore, 21 divides every element of T. So, these are the favorable outcomes. Agreed? So, now P, the probability is the number of favorable outcomes by the total number of outcomes. That is equal to the number of elements of S which are multiples of 21 by the order of the sample space. That is equal to the order of T by order of S. That is equal to order of T is 22 by order of S is 64. That is P. We wanted 96 times P. 96 times P is equal to 96 into 22 by 64. Simplify, you will get 33. That is your answer. So 96 times P is equal to 33 is our answer. That is the detailed discussion of the solution of the problem from the section probability and statistics, and I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.